Here's kind of a cool animation. Force equals mass times acceleration. We've got to sing a song. Force equals mass times acceleration. Acceleration times mass equals force, etc., etc., etc. No? That didn't work for you? Okay. Hey, actually, let me just do one other thing here. If F is equal to ma, I want you to write this down. What is A equal to and what is M equal to? Well, we can do some simple algebra. Algebra, is that a dirty word? I don't think so. All right, if I divide the both sides by M, what happens to the M on the right side? Well, right here. That's the right, the M cancels. And so we can say that A is equal to F over M. So that would be like a second equation, wouldn't it? All right, we could do another one. Let's do another one. What if I say, I'll do it over here, F is equal to ma, FMA. Okay, I could divide both sides by acceleration, right? And then the A cancels on the right side, and I can say that M is equal to F over A. So these three equations, this equation, and of course the master equation, F is equal to ma, those three equations are really the same equation, just rewritten in a different way. You should definitely copy this down in your notes. I think that'd be a very good idea. Don't you think? I think so. All right. Okay, now, let's do another short little video clip about different masses with the same force. May the force be with you. Okay, we have a problem here that relates to an airplane. I got the calculator up there. We have a Boeing 727. Okay, so we've got the Boeing 727 here. Oh, I messed up, didn't I? Hold on. I messed her up. Okay, I got to do a shift to control P. Okay, I got my pen back. Okay, so we have a Boeing 727. It has a mass of this many kilograms. What is the lift force required to get it off of the ground? Well, our key equation is F is equal to ma. So what do I know in this equation? Well, I know that m is equal to 396,900 kilograms. Now, we're trying to get it off the ground. Now, we're going to make an assumption, I think a pretty reasonable said, that you're on the Earth, right? Plane would probably be on the Earth, and so the acceleration is this number we talked about earlier. It's 9.8 meters per second squared. So if I want to find the force, I would say F is equal to m. Now m is 396,900 kilograms times, that's a parenthesis there, times 9.8 meters per second squared, parentheses. And so now I go in my calculator. Oh, I love calculators. 30. I can't hit the button. What's the button here? So I will take 396,900 and I'm going to times it by 9.8. Right? Just put that on my calculator, and I get a big old honking number. I get 388,9620, and that is in kilograms meter per second squared. Or now we could probably round that out here. That is like 3 million. Let's just call that 3,900,000. We'll just kind of round, and that would be newtons. So that would be the answer to this problem. So that's not terribly difficult, is it? All right, now let's take a look at a second problem. Where did it go? I have a second problem. Where did it go? My second problem has disappeared. I must find. Okay, hold on a second moment, okay? And here we have an upward force of 1,500 Newton is applied to a 10-kilogram model rocket. What is its initial acceleration? We kind of need to draw a picture on this guy. This one's a little more confusing. Okay, so we got a rocket. Okay, does that look like a rocket to you? Okay. Okay, a little baby rocket. He has a mass of 10 kilograms, and they apply an upward force of 1,500 newtons. What's the initial acceleration? Well, there's actually two forces applying, if you think about it for a moment. This object has a particular mass, right? So if you were to think of it, there's a force going downward. That, of course, would be the force of a gravity. And the force of gravity is going to be equal to F is equal to ma. Okay, so let's do the downward force. There's a downward force and an upward force. This is the upward force, but I have to calculate the downward force, and then I'm going to subtract. Okay, so the force upward would be equal to ma. So the mass of this object is 10 kilograms. All right, and the acceleration of gravity is 9.8 meters per second squared. And so if I go back over to my calculator, I take 10, probably could do this in my head, right, times 9.8. That would be 980, isn't it? Or 98, pardon me. This is 98 newtons. So it's going to be going upwards at 98 newtons. Or downwards. This is the downward force, pardon me. Well, if we have an upward force of 1,500, so we've got a big acceleration, there must be a good engine in this particular rocket, then you'd take 1,500 newtons minus 98 newtons. And that will be the initial number of newtons that will get this rocket going. So I'm going to go back to my calculator. What is 1,500? Subtract 98. I get 1402 newtons. So the actual upward force is only 1402. That's still pretty good. And so now I'm going to try and solve for the acceleration. Now to solve for the acceleration, as you recall, we said F is equal to ma, but if we divide both sides by m, the m's cancel, and a is equal to F over m. Well, our upward force, that's what we're trying to calculate, is going to be 1402 newtons, and we're going to divide by the mass, which was 10 kilograms. Now, I really don't need to do this in my head, but I'll do it on the calculator just for fun. 1402 divided by 10. This is going to accelerate. This is going to be quite a rocket. This is going to accelerate at 140 meters per second squared. It means every second it's going to go 140 more meters per second. It's very, very high acceleration. I think I probably was thinking this problem, I was going to make this 100 kilograms, and then it would be like 14, which would be a more reasonable number. But hey, that's how the problem worked out. That's how you solve the problem. You'll get problems like that in your notes. So that's the end of this podcast. We'll see you in class. Bye.